Okay, so a very good afternoon, and a very warm welcome to the this last session of this particular workshop, 5 days workshop, that is computer networks and insight. So up till now, we have gone through the basics of computer networks, such as what are the different types of devices are available, how we are going to construct the network, what are the different types of topologies are there, how logically we are going to connect the devices, and not only that, but also the stack, that is TCP/IP stack, ISO/SI model, on which different uh, protocols or devices are available, and the data in each layer will be treated with the different name, such as if I'm talking about data link layer, we can call this as an frames. The data we are talking as a frames in data link layer, packet in the network layer, segments or chunks in the your this, that is your transport layer. Okay, so in this way, now today is again, and later on we had the hands-on session also, that is on Cisco packet tracer tool. So today we're going to study one of the very basic and very important tool that is required to analyze the contents of the packet. So if I'm saying the devices are communicating with each other, then they are transmitting the data in terms of packets or frames or data chunks or segments. So the data, that is your payload, will be having again the header as well as trailer. So what header consisting of, what trailer consisting of? Initially, if you want to analyze this thing, you should be capable of understanding thoroughly the different types of protocols and their datagram formats. So I think now today's session is about, that's one of the popular tool, that is Wireshark packet analyzer tool. So how you are capturing the real-time packets, those are sending and receiving to and from your network, and how we are critically analyzing these packets. So today, before going to have this brief introduction, so you should know about what is at least minimum IP4 header datagram format. So initially, as I mentioned, the IP version 4, its location is on the network layer. Okay, so these are the some of the protocols available at the network layer, such as your IGMP, that is Internet Group Management Protocol, ICMP, Internet Control Messaging Protocol, then IP version 4, Internet Protocol, ARP, that is Address Resolution Protocol, and Reverse Address Resolution Protocol. So in some cases, okay, at least you should know the details about IP version 4 header datagram format, and that is why we're going to first study or understand what can be the content of IP version 4 datagram, so that we can analyze and see all these terminologies in your Wireshark packet tool analyzer. So if I am talking about one packet, what packet consisting of? Now it is shown that it consisting of the very basic and very starting point as a header. So this section we can call this as a header, and if we zoom or if you analyze this header, it consists of so many parameters. Those are written in this block, and after the header we have your actual data that you need to carry. Okay, just like take a real-time example, if you want to send a letter, so whatever the content you have written in the letter, that can called as in here data, and the addresses, that is to address, from address, envelope sealing, that is encryption providing, that everything is available with the header. Okay, so normally IP version 4 datagram format will be having a maximum size of 65,536 bytes, that is 2 to the power 16 is the maximum size of the packet. Out of it, the header is variable in size, that is the basic header is of 20 bytes, and it can
Hello. I guess you're on mute, sir. Or we lost you.
हॅलो सोनटक्के सर.
Ma'am, sir left
I
the.
guess, yeah, I guess he left.
Oh, is it? Okay, I guess he's facing some kind of a network issue. I'll let him
Yeah,
know.
could you please, yeah, please,
Yeah, yeah,
could you please
definitely.
call them and ask
Yeah, yeah, yeah.
or check?
Yes. Yes.
Okay, actually, I disconnected. I'm extremely sorry for that. Okay, due to the internet connectivity, I lost it. And okay, let us start with again. Okay, so am I audible? Can anybody acknowledge it?
Yes,
Yes, sir.
it is now.
Yes,
Yes,
sir.
yes. Thanks a lot.
Now.
So I was on to this particular header datagram format.
Yes, but the thing is, you didn't draw these figures.
Okay, 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 okay. So I'll come back again. Okay, and we'll see once again what can be the content again here. Yes. Now, if I'm talking about the total size of IP version 4 packet, it will be consisting of data and the header. Okay, so the total size can be 65,536, which is 2 to the power 16. That can be the maximum size of packet that can be carried by from one device to other device. And out of that, the header size is from 20 to 60 bytes. Okay, so the basic header size is 20 and it can be extended with the help of this optional field, and it will be up to 60 bytes. So in IP version 4, the header size is your variable, but the basic one minimum 20 should be there. Now let us zoom out this section, zoom in this section, header, and what can be the different parameters associated with the header. And that we are going to discuss in your Wireshark packet analyzer tool. So very first 4 bits are reserved for defining the version of your IP address that we are using or the devices are using. Okay, so if first 4 bits are reserved, and if you are using IP version 4, so 0100, this is the your binary representation of your 4, that is IP version 4. This is 1 2 4. Okay, means it is binary representation of IP version 4. If we are I'm using IP version 6, so it can be 0100. Okay, so it is the binary representation of value 6. So that is why first 4 bits are reserved for identification of the version that the devices are using. Okay, next 4 bits are reserved for defining the length of the header, that is this one. So that can be represented by HLEN, that is header length. So if I am saying that the 4 bits are reserved, now how this header length can be represented? What can be the minimum value? So the basic header length is 20, and if 4 bits are reserved, so I can write it here, 4 bits multiplied by, if it is minimum 5, then we can say it is the basic header length is 20. Okay, so your header length must be starting from 5 onwards. Okay, it should not be less than 5. If it is 4, then 4 4s are, it is 16. So 16 could not be a size of your header. It should be minimum 20 bytes. Okay, and if I'm saying it is a 60 bytes total, so what can be the header length value? So it is, yes, 4 into 15. Okay,
15.
so
Yes.
15 forza, 15 forza is total 16. Okay, means it is 60. So I can say that this particular header length field can vary between 5 to 15 only. Then and then only it is valid. Otherwise, it can be invalid header length. So in certain examples, I'll just going to show you that also, how to identify whether the packet is invalid or valid one. Okay, so you can remember this point. Next, 8 bits are represented as services offered by the devices. Okay, so what kind of services that can be offered? So let me show you the next line. Okay. Now see, if I'm talking about brief about the services type, we have 8 bits for this. Out of that, so first 3 bits are not in use and last bit is also not in use. Out of that, only 4 bits are represented as DTRC. So what is this DTRC? The first D stands for the delay. Okay, so whether we need to increase the delay in a network or decrease it, definitely we need to minimize the delay in a network. So what can be our aim? We need to minimize this. So that is why your first service is minimizing the delay. Second one is T, that stands for the throughput. If I am sending 100 packets from one device, all the 100 packets should be received at the receiver, so that I can say throughput is 100%. If out of 100, 50 packets are lost, so the throughput is only 50%. Okay, so I need to maximize this, so that if your network is very much congested, the huge traffic of the packets, there might be having the chances of collisions of the packet, and because of that, the throughput might be dropped or it will be minimized. Okay, or it can be decremented. So our aim is to maximize it. What can be the next? That is the reliability. So how we can say that this communication is reliable? So if the device is sending 10 packets and without an error, all the packets are received, means whatever the medium that is being used, it is reliable. Yes, we are confident enough that whatever I am sending is definitely it will be received. Okay, that is why we can say it's a reliable communication between the source and the destination. And finally, the costing value. The costing value is nothing but it is the value or the distance between the one device to other device. So in the network, in the internet, if the data needs to be carried, so always the router will try to find out the shortest path distance with the help of different algorithms. You might be studied. One of them is just like an Dijkstra.
OSPF.
Yeah.
OSPF.
Yes, OFPF also. Yes, very good. And Dijkstra's algorithm as well. Okay, so it will try to find out the minimum shortest route, and it with the help of the costing values also. Okay, so that is why depends on what kind of services it has provided. These 4 bits are reserved for it. Okay, and these are the sum of the bits, how it is being represented. If all these 4 bits are 0 0 0 0, it will be considered simple and normal packet. Okay, if it is 0 0 0 1, it will be going to minimize the costing value. If it is 0 0 1 0, it is having a good reliability, then the next good throughput and the minimum delay. So if I'm talking about now, currently I am connected to you with the help of virtual connectivity. So whatever I am talking, it should be reproduced at your end with a fraction of second without a minimum delay. Okay, we can call this term as jitter in the communication. Okay, so it should have minimum jitter or minimum delay. So for real-time applications, definitely we can go with this particular option. Okay, so these are the services provided by. So here the total 8 bits are reserved for defining the services offered by the packets or the devices. Next one, it defines the total length of your packet. How much is the size of your packet can be defined with the help of 16 bits. Okay, I'll come to show you once we go with the next part. There is a fragmentation that is needed here, and in that you should know the total size of your data or packet. Next one is the identification field. What is identification? Now take an example. You are using multitasking system. Nowadays your laptop, mobile phones, all the devices are, it's a good processing or high processing capability devices where we can use multiple applications simultaneously. So suppose I'm using one of the application as WhatsApp, other as in Facebook, okay, other I'm browsing some data. So different packets are generated from these applications. So how to identify it? And that is why we have this identification pattern, okay, or one unique numbering that will be 16 bits that is reserved for it. Okay, if one packet is coming or some of the packets are coming, you can isolate or you can identify it. These packets are coming from WhatsApp application. This is coming from the email client. Okay, in this way, that is why we needed this identification field. Next 3 bits represents the flag. But what is this flag? Let me go to the next slide. Yes, these are the 3 bits represented as a flag. The first bit is reserved, but the second bit is represented as D and third bit is represented as M. D means stands for do not fragment. So fragmentation is a process of dividing a packet into small number of packets. So again, the question might be coming into your mind, why we need to fragment the packet? So I'll just giving one example. Suppose I'm having a file of 10 MB and I'm uploading it on a cloud or internet. Okay, and a point will come, it is uploaded up to 99.99, and if some error has come, or suppose I got disconnected from the internet and that uploading fails. Now what happened? I need to again upload that whole 10 MB of packet. It will take lots of time. But instead, why not we can divide this packet into 10 or 100 number of packets, and some sequencing number should be given so that we can identify the sequence. Okay, and those packets can be transmitted in a network. So if the problem is happen at 99.99, only that last packet, which is a very small in size, that can be suffered. Okay, and the time required to upload that small packet is very less because the remaining packets have already been uploaded onto the cloud. And that is why we needed these fragmentations. So if this bit is set to 1, the devices would not be have the there is a provision to fragment the packet. But if this M bit is set to 1, means more fragmentations would be allowed if necessary. Depends on the conditions in the network. The devices, intermediate devices, can take the actions and fragment the packet as well. Okay, so these are the 3 bits set for this fragmentation. Okay, after these 3 bits, we have the fragmentation offset value. Now, what is this fragmentation offset value? If your packet is, suppose I'm having 4000 size of one packet and I'm dividing into 1400, 1400 and 1200. Okay, so this fragmentation offset value, I come to know what can be the starting value of my packet. Okay, so once it is divided, I should understand so from where this packet is started, and that is why this fragmentation offset value plays a very important role. I'm going to highlight in details about it. Okay, let me give that example first. Yes, this is a fragmentation. Now see, if I'm having this particular packet which is having a total size of 4000, if it starts from 0000, it ends with 3999, so total overall size is 4000. Okay, and if I am now, how I am going to find out the fragmentation offset value? So I always take the first byte of your packet and it divided by 8. Okay, I'm taking the first byte of my packet and it is 0000 divided by 8, and I gives the value offset value. Okay, now in this case the 4000 is the size of packet divided into 3 different sub packets. Okay, now in first one the size is from 0000 to 1399, that is the size of 1400. Remaining is the size of 1400, and this is remaining 1200. Okay, so 1400, 1400 and 1200, it will contribute total 4000. Okay, now see, initially if it is starting from 0, then it will be end with 1399. Next byte starts from 1400 to 2007, that is 2799, then 2800, and then finally 3999. If I want to find out the offset value, what I can say, I can take this first byte of all these packets. So in first case 0000, I'm dividing it by 8, my offset value will be calculated as 0. In second fragmented packet, I can take 1400 divided by 8, I can come to know the value would be 175. And in the third packet, it is 2800, I can take it and divide it by 8, I come to know that it is 350. Now see, if I come to know this offset value, can I find the first starting of your packet? Yes. What I need to do? Simply I need to multiply this offset value by 8, because earlier it is divided. So 175 into 8, it gives the value of 1400. So I can say that 1400 would be the starting of the fragmented packet. In first case, if it is 0, if I am multiplying it by 8, it gives again the starting value 0. Is I can say it is the starting of or first fragmented packet. Okay, and in last one, if it is 350 multiplied by 8, it gives the value of 2800. Okay, that is the starting value. Okay, and that is why to find out the starting value of your fragmented packet, the fragmentation offset value plays a very vital role, and that is available here, fragmentation offset value, and 13 bits are reserved for it. Next 8 bits are reserved for time to live. So as I mentioned, while pinging the destination, we have TTL, that is time to live, that is the lifetime of packet. What is this lifetime of packet? This packet can travel through how many routers, how many hops. Okay, so if it is 100, then it could cross the 100 routers, and if it crosses 100 routers, it will be decremented to 0. If that packet is visited to one router, it is decremented by 1. In this way, once it visits the 100th of router, it is fully decremented and it is goes to 0, and that packet would be dead in nature. They cannot travel more. Okay, so this TTL field is very much important. And next, the protocol. So 8 bits.
Hello.
Yeah.
I'm sorry to interrupt you, sir.
Yes.
Actually, sir, right now you have told about the time to live, right?
Yes.
If time to live or the hub count number will be 100 and the destination computer is within the 100 or within the 50, is
Yes.
it okay with the packet transformation?
Yes, if it is lesser, that would be good for the packet. Yeah, because the device is very least. That is why it will always try to find out the least distance. Yeah.
Okay.
Some
Okay.
alternative
Understood.
ways will be find out, and it could receive the packet within that particular TTL.
Yes, it means not. It is not necessary to have a complete the given number of the routers, right? So we are giving the maximum limit of the
Yes.
router reach,
Yes, definitely.
right? Okay.
Yes.
Okay, sir. Right. Thank
Otherwise,
you.
sometimes what happen, you are browsing the web portal, but you are getting the error
Error.
messages.
Yes.
So
Yes.
that
Unreachable.
request would not be resolved. That it will crosses that TTL also. Okay,
Okay,
that
sir.
might be.
Okay, understood, sir.
Yeah.
Thanks.
Okay. The next one is your header checksum. So what is the this importance of header checksum? If there is a problem with your header, now if I said one example, if you're writing a letter and your to and from address are erased or will be having some issues while handling the letter, then it will that will going to lost your that packet or your letter. That will be not having any meaning to whatever the content you have written in your letter. Okay, so this header checksum is utilized to identify the errors in your header, and it will try to rectify it also. So router will going to analyze it and try to identify whether this header is error free or errorless. Okay, so these 16 bits are reserved. And finally, the IP address, that is source IP address and destination IP address. Now, if you can add all these bytes, let us see what can be the size of header. Now, first 4 bits for version and next 4 bits of header length. 4 plus 4, it is 1 byte. Okay, 8 bits means 1 byte. Remaining services, 8 bit is again 1 byte. Then next 16 bits are 2 bytes. Okay, next 16 bits for identification, again 2 bytes. Next 3 plus 13, that is flag plus offset, fragmentation offset, that is 16 is again 2 bytes. TTL and protocol 8 plus 8 is again 2 bytes. And header checksum is 16 bit is again 2 bytes. And if you count it, 2 plus 2, 4, 5, 6, 6 plus 6, which is 12. So total 12 bytes are up to this header checksum. Now, what is the size of IP? Can anybody tell me? IP version 4 we already discussed.
32 bit.
32 bit. If it is 32 bit, means how many bytes? If I am dividing into 8.
2 byte.
4.
4.
4
So
bytes.
this is 4 byte. This is 4 byte because source and IP address are same size. So 4 plus 4 is 8, and 8 and plus this 12. So how
8
much?
byte.
It is 20, and that is why the basic header size is having the total size of 20 bytes. And if you're observing this option field at the bottom, that might be having some other parameters. Those are optional one that is required based on your real-time applications or some other different types of applications. Well, that will be contributed remaining 60 bytes. But at least you should understood these basic parameters of your header. Understood?
I'm sorry, sir. I'm
Yeah.
sorry, sir. How you have calculated that 20? Could you please repeat?
Yes, yes. Once again, now if I am adding version plus header length, 4 plus 4, it's 8 byte. 8
Yes.
bit means 1 byte.
Yes, 8.
Yes. The services requires 8 bits means again 1 byte.
1 byte.
Then total length carries 16 bits means
2 byte.
byte. Then identification carries 16 bits, again 2
Again
byte.
2 byte.
And flag plus fragmentation offset, 3 plus 13 is 16, means
16.
it
2
is
bytes
2
again.
bytes. TTL plus protocol, 8 plus
Okay,
8
understood.
2 bytes.
Understood. Okay.
Okay, and remaining 2 bytes. If
The
you can
source
add
IP
this,
will be 4 and the destination IP will be 4. Okay.
and this will be 12, and remaining 4 plus 4, 8. So it is 20.
Yes, sir. Thanks.
Understood? Okay, so at least once you know this, you can able to grasp how we are going to analyze the packet. But before that, I just want to take one exercise. And one more thing, as I mentioned, whatever the data that the devices are carrying, okay, the data can be encapsulated. Okay, because their usage might be different. Either it can use TCP protocol, either it can be use UDP protocol or SCTP protocol or OSPF, ICMP, IGMP. The devices, the data can be encapsulated. Okay, your raw data is filled in to the specific size of the packet. So TCP would be having their own size, UDP is having their own size. So every packet depends on the application, would be having their own sizes, and the raw data that is being transmitted is added into this particular capsule or packet, and that is why the term is encapsulation of data. Okay, so if this field is represented by 1, the data is encapsulated with the help of ICMP packets. If it is 2, then it is IGMP. So these value will indicate what type of data or the data is encapsulated with the help of which protocol. Understood? So I'm now going for the exercise mode. Okay, before that, I'll give one example how the fragmentation has been done. Now suppose this is my first packet and I have taken the first example only. This is the example, I am exploring it. Okay, what is the size? It's 00000 to 3999, means total 4000. This is the actual size of data, your original data. And if you're observing here, the total size is 4020. So what is this 20? This 20 is nothing but your header size. Okay, that is the basic size. Okay, and if you're observing, this is your identification field. This is your, can anybody tell me what is this field? 10. Yes, this is last one is fragmentation offset value. What can be the value before it? Let me go back again so that you can recall it. Now see, before the fragmentation offset you have the flags. Okay, this flag is very important, and from that you come to know that whether this packet is fragmented or not. Okay, so actually it should be 1. Okay, by mistakenly it is written 0. It should be 1. Okay, and as it is represented as 0 offset value, means this is your starting one. Okay, and if it is bit is 1, means more fragmentations would be allowed, and that is why this packet is divided into 3 respective packets. The first size is 1400, second is 1400, third is 1200. But I have added the basic header value of 20, that is why it is 1420, 1420 and 1220. Okay, and one more thing, how I come to know this offset value? These sizes are offered 0 to 1399, first 1400, remaining this value and remaining this value. Okay, so if I am taking this first value and divide it by 8, okay, as I mentioned earlier, I can get these values. So here first case, let me go back. Here you got this 0, 175 and 350. Okay, after dividing it by 8. Okay, these same things are over here, 0, 175 and 350. Understood? And again, if this this flag is again bit set to 1, means this packet can be fragmented again more. Okay, now again this this packet can be fragmented and divided into 800 and 600, because the total size is 1400 here. So 820, it is the added value of your header, and here 620. Yes. Okay, so here again your first
Sir,
yeah,
actually the 820 plus 620 would be the 1440, right?
pardon.
Yes, sir.
The,
Addition of 820
yeah.
and 620.
Yes,
Yes,
now
yes, exactly.
this
The same
20 is optional. That is nothing but your header size. Okay, so here consider it is 800. Here consider it is 600. So 800 plus 600 is 1400, and this is the size of your second byte. That is your packet 1400. Because we divided this 4000 into 1400, 1400 and 1200. Okay.
Okay.
So that is why
the bytes would get fragmented but the count of that what you said 4020, this will not fragment like equally, right?
Oh,
The
which
820
one?
like and 620,
Which one?
820 and the 620 from the 1420.
Yes, this one. So this is added one. This is the total size of your packet. That is including the header, but we need to exclude it. Okay. So for calculation of your data. Okay. So it is 800 and 600 only.
Okay, understood, sir.
So
Thanks.
600 plus 800 is 1400. And now if you can observe, these bytes are starting from 1400. So if I divide this by 8, so 1400 by 8, it gives the value of 175. And if in this case it is 2200 divided by 8, it gives 275. Okay, so if I come to know the offset value is 275, I can multiply this by 8. I can come to know that the starting value is 2200. Understood? Love you?
Yes, sir.
Yeah. So on this, I'm just taking one small exercise. You need to give the answers if the concepts are clear, and later on we can see it in the Wireshark tool. Now let us see one example. An IP version 4 packet has arrived with the first 8 bits. Now first 8 bits are shown like this. Now receiver will discard this packet. You need to tell why. If you understand
Sir, they
the
are header.
Yeah. Why receiver cannot accept this data with the starting bits? What is your starting parameter of header datagram?
Version and header length.
Version. Yes, definitely. Version. How many bits are reserved for version?
4
4
bits.
bits.
4 bits. If it is 0, 1, 0, 0. Yes? If it is 0, 1, 0, 0, what is the version?
4. IP version
4.
4.
It will be
It will be using IP version 4, and remaining 4 bits are reserved for header length. What can be header length in this case? 0010 means it is 2.
1.
it is only 2. Yes.
2. Then header length should be between 5 to 15, as I said. The basic header length must be 20 and maximum up to 60 bytes. Yes, but here it is shown 2, and that is why destination system will discard this packet. Understood? It will never accept it. It is invalid header length. Understood? The first one? Any doubts?
No, sir.
Okay. Now, next exercise. In an IP version 4 packet, the header length is given now. 1 3 times 0. That is in binary. Okay. How many bytes of options are being carried by the packet? Who can give this answer?
Right.
How many optional fields are taken? The basic one is 20 bytes. How many optional bytes that packet is carrying if header length is 1000? Now see, if I am converting this binary into decimal, what is the value you are getting?
8.
Yes, it is 8. Okay, 8 multiplied by 4. That is the header length represented with the help of 4 bits. 8 multiplied by 4 is
32.
32.
32. So, what is the basic header length?
20.
20. If I am subtracting 20 from 32, how many optional bits are there? Bytes are there?
12.
12.
12.
bytes.
So yes. So the answer is it carries extra 12 bytes of information because your basic value is 20 bytes. Okay. Yes. Next, the third exercise. In IP version 4 packet, the packets are arrived with the first few hexadecimal digits are given. Okay. And you need to observe it here. How many hops can this packet travel? Now for this, you needed the reference of this figure. Yes. Now your TTL is on which position? Now see, I'm now counting the byte size. Okay. Header plus version is 1 byte. Service is another 2. Then 2 plus 2 4. 4 plus 2 6. 6 plus 2 8. and after 8 byte TTL will arrive. Okay, so I need to go with the same one, and I need to skip first 8 byte of data. Okay, so first 8 byte of data means 2 hexadecimal contributes 1 byte. Okay, so this is the first byte, second byte, third byte, fourth byte, fifth byte, sixth byte, seventh byte, and eighth byte. Means this is the actual number we want. So this is the TTL. What is the TTL? It will only cross only one hops, that is one router, and then it will be dropped. Okay, so its value is 0, that is time to leave. Okay, that is in I think if you have understood or studied the IGMP protocol, Internet Group Management Protocol, it is the local protocol. Your devices cannot transmit the data beyond that network, so its TTL must be always 1. It can transmit within the network only. Okay, that is the kind of one example I have shown. Next one, a packet has arrived with M bit value of 0. Now see, what is this M? This is the flag, whether it is more fragmentations are allowed or not. Is this the first fragment, last fragment, or middle fragment? Can you comment on this? What happens if M equal to 0? Whether more fragmentations are allowed? Yes or no?
No.
No.
No, sir.
No. M is 0, then fragmentations are not at all allowed. It might be the last fragmented value or packet. We don't know earlier what happened, but it might be last one, but we never refragment it again. Okay. Next one, the packet has arrived with M value is 1. Now we can fragment it. Yes, if M is 1. Now, is this the first fragment, last fragment, or the middle fragment? Can anybody comment it? Can we do the further fragmentations if M equal to 1?
Yes.
Yes, definitely. So I can say that. So we can do it again, but we cannot say. We don't say if it is first one or middle one. We cannot have. We needed some more data to find out whether it is the first fragmentation or the middle one. But we can say that it could not be the last one. Yes, that is the guarantee because M is 1. More fragmentations would be allowed. Okay, at least means we have that reference data. But if the data is known to us, now I want this answer from all of you. Now M bit is set to 1, means more fragmentations are allowed, and offset value is 0. Then can you tell me whether it is the first fragment, last fragment, or middle fragment? If I am multiplying, what is the importance of offset value? If I am multiplying by 8, it will give me the starting value of your packet. First one?
Yes.
Yes, very correct. Yes, means this is your first fragmented because your offset value defined as a 0. Okay, more fragmentations would be allowed in future because M is 1. And next, final one, the packet has arrived with the offset value of 100. Okay, and what is the number of first byte? Can you anybody try this at least? Offset value is given 100. Can you able to find out the first byte?
800. 800.
Definitely. If you multiply by 8, it gives you the first byte. Okay. I think there is again one more thing which is interesting now, somewhat complex. You need to understand now. The offset value is given 100 and the header length is also given 5. Okay. And the total length is given 100. What are the number of first byte and last byte? Offset value is 100, header length is 5, and the total length field is 100. What are the numbers of first byte and last byte of packet? Okay, let me clarify it. Now, if offset value is 100, if I am multiplying with 8, I could give, yes, the first byte, 800. Okay. What is the header length? 5. 5 multiplied by 4 is 20. That is the basic header length. Okay, that I have shown here. 5 multiplied by 4. That is your 20. So means what I am here, the total size is given as 20 if I am subtracting the header from it. So 100 minus 20 is 80. Okay, 100 minus 20 is 80, and if starting value is 800 and I need to add this 80, so it is 879 would be the last byte of your packet. Means this packet starts from 800 and ends with 879 because 20 bytes are gone to your basic header. Understood?
Yes, sir.
Okay, so now I'm moving towards, once you have this brief introduction, now you can go with the introduction of Wireshark. So this is a very popular network packet analyzer tool, okay, and it is very much, it is open source and freely available, and we can use it on Windows as well as Unix platform. So why we are using this Wireshark platform? So normally network administrators are used to troubleshoot your network problems. It is not restricted to only the network administrators, but the security engineers, network security engineers use for examination of the security problems. Along with the network problems, you can go with the security problems also. Developers can use for debugging the protocol implementation. Means there are lots of applications are there. Testers use it to detect the defects in your system or the protocols. The same way, the people can use it to learn the network protocol internal. Just currently we are doing it. We are trying to learn different protocol contents in a minute way. That is internally. And we can say that this network packet analyzer will try to capture the network packet and tries to displace the packet data and detailed as possible. We are scrutinizing each and every packet in detailed way. What is associated with the header? What is associated with the data? Everything we can analyze it. Okay. But it is not an intrusion detector. We could not able to detect the attack, but we can identify it. Okay. That is why intrusion is nothing but a malicious attack. It is not able to detect it, but at least it will going to identify it. I'm going to give the demo as well. And Wireshark will not manipulate the thing. It is only used for your measuring the things in your packet. Okay. Now you can easily install it in your Windows as well as Linux content. But this will look like the front view of your Wireshark tool. That is, you have this command menus. We can have here the filter option. Whatever the content that we'd like to search, you can simply type it, and according to that the packets can be listed. Okay, this is the section where multiple packets have been shown. Okay, real-time packets I'm talking about. The detailed, if I click one of the packet, you could come to know what is the content of that packet layer wise. I can show it also after this. And finally, the data would be represented in ASCII form. That is, the computer knows that language. Okay, your user knowable language is converted into the machine level language, and that level language ASCII code is written in this platform. Okay, I'll show you that. Now I'm just going to show a few data or demos. What happened, whatever we have discussed in IP, I show it on, that is IP header datagram. What happened if you are pinging the destination? What happened if I am surfing the web page? Telnet login. So first I'll take this example, that is telnet. Okay, means that is how we are going to take the login, remote login on the device. So I'll show you that. Now let us see. I'm just opening the packet analyzer. That is your nothing but the Wireshark. Okay, once I am opening it, is my screen visible?
Yes, sir.
If I am opening it, it will ask for what is the interface that you are currently using. Whether it can be your local NIC card or wireless NIC card, and the traffic would be, again, if you are observing it here, I am using my Wi-Fi network, and the traffic, the graphs are shown here. So definitely I can select the Wi-Fi, and instantly whatever the traffic or the kind of protocols currently at the back end of the system, okay, is transmitted and received, in which you have the number of packet sequence number, then the time at which the packet is being transmitted, the source IP address, destination IP address, what type of protocol currently it is transmitted, what is the length of that protocol, and their information about it. Okay, so and below that, if you're observing, there are multiple layers are observed. This frame layer is related with the physical link layer, the Ethernet is related with your data link layer, internet protocol is related with your network layer, transmission control, that is your transportation layer. Okay, now what I'm going to do, I'm using one client system for login. I think many of you are aware about it, that is Putty. Okay, this Putty is very popular client for logging to the destination device remotely with the help of SSH or Telnet. So what I'm going to do, I'm simply typing the IP address of my router currently I'm using. Okay, it is 192.168.0.1, and I'm using here a telnet command. Okay, so here in this tool we have this option to capture it, to stop it, or to reset it. So I'm currently stopping it. So whatever the packet I have, I can examine it at any instant of time. Even I can export it also. Okay, I can export it, depends on the packet or depends on your overall bytes or PDUs. Okay, now what I'm going to do, that I'm starting it again once again, and I'm logging to my router. Okay, and I'm using now login credentials, that is admin is a username of my password, and PCCOE$123. It is not visible, but I have entered it and I hit enter. Now I have logged on to the router. Now I suppose I'm using dir, that is directory location. So up till now I stopped this particular capturing mode. Okay, so here I have logged into my router, and now I show you how anyone can able to access the username and password that you have unsecurely used. So what I'm going to use here, I'm using telnet command, that is filtering it. I come to know that these many telnet commands I have used it. Okay, and now see, okay, sorry. Okay, so if okay, now if I am now exploring this telnet and I simply go to check the contents one by one. If you can observe here, under the telnet, the data is sent A, that is for admin A. I get the response immediately, that is A. Then D, I get the response D. You can observe here, M, getting response M, I, that N, that is admin. Okay, that is the data one by one byte that I'm sending, that alphabet. And I got again the what can be the password. Okay, I can get the password first is P, then C, then C, O, E, PCCOE, $1, 2, and 3. But you can also see in detail if you can go to the statistics and okay, no, sorry, go to the analyze, go to the follow, and go to the TCP stream. Now see, whatever I did, everything is recorded, and now see the username, it is shown admin, but acknowledgement is written. That is why AA, double D, double M, double I, double N will be shown. Okay, and along with that, now see, you can capable of observing my password also. That is unsecured. That is why telnet is very unsecured way of logging to the any devices. Okay, and not only that, whatever the command I have used, that is dir, is also listed here. Okay, so in this way we can say that how we can able to find out whether the data is securely logged in or unsecurely logged into that. Okay,
Hello.
so in this way, yeah.
I'm sorry to interrupt you, sir.
Yes.
Sir, in the Wireshark, whenever we have started the scanning for the all activities, right?
Yes.
When you have given the destination IP or the target IP, we can say.
Here I have entered initially. I need to connect to the router. That is why it is given 192.168.0.
No, it is in putty, right?
Yes,
So
it is.
Wireshark is directly connected and scanning with your Wi-Fi network only.
Yes, currently while starting the Wi-Fi, this Wireshark, I have selected the interface as Wi-Fi. I showed that, and that is why all the packets
Yes, I
can be
understood that.
captured.
I understood. Like you have started at the starting of the Wireshark, you have selected the Wi-Fi, right?
Yes, yes.
But you did not select the target or like the specific IP address or the specific access point or the specific router, right?
That I have provided in putty.
Okay, it means Wireshark is showing all the activities from the existing Wi-Fi, right?
Yes, yes. What is the traffic that is being coming and outgoing? Everything we are going to observe it here.
Okay, it means if there are any another access point or router will be there, Wireshark will scan this also.
Yes, yes, definitely, definitely. That is
Okay.
depends on you are connected to what network, whether it's a wireless or wired also.
Yes, exactly.
Yes.
That was my point.
Yeah.
Now you are connected with a specific router only, right?
Yes, yes.
So if there are any multiple routers or is there any other routers will be there in a network, in your network only, or we can say the another access point we can say, right?
Okay.
So Wireshark will not scan the another network other
No,
than your
it is
connected
within
Wi-Fi.
the network. It is within the network only.
Okay, and Wireshark does not require like a admin access, right?
No, no, no. Initially, it is not. But what happened? Always because it is a kind of it is, as I mentioned, it is not an intrusion detection system. It is not an invalid kind of thing. We are going to only analyzing the thing. It will never going to change the content of your network.
No, I understood that.
Yeah.
The thing is, see, I'll try to present the scenario exactly.
Okay.
Now you are on your system, and I am also in your network
Okay.
via Wi-Fi, you can say, and
Yes.
you're scanning Wireshark from your laptop, and
Okay.
I am working on putty.
Okay.
Right. So is it possible that you will be get the access or you will be get the results that what I am doing from the putty?
Yes, yes, definitely. Because you are
Okay.
logging to the router. Router is the main actual gateway.
Okay, right. That's
Everything will
what
be
that I
captured.
wanted to know if the admin is already working on the router, right? Admin is already working on the router, or we can say the connected on the router,
Okay.
and admin do not have idea that somebody has scanning me as well, right?
Okay. Yes.
Okay, thanks, sir.
Yes. Yes. Okay. So let me go to the next point. So what happened? Now I'll do one thing. I'll do one real-time attack that you might be aware about. That is DOS attack. That is denial of service attack.
Daniel
What
of
is this?
service, yes.
Yeah. So what is this attack actually? Now, if I could observe it now, here it is.
It
It's a
makes
one attacker.
yes, it makes the target unavailable, right?
Yes, it
Or
will be
hang.
simply what you can say float n number of packets, and it will going to overwhelmed or the network or stop the network, so that it cannot be available to rest of the users because your network is very much crowded with the packets. Okay, so for that I can show you that demo. So I'm using here one tool that is very popular tool, that is LOIC. Okay, so this is the long form is a low orbit ion cannon. Okay, and whatever the target device you need to attack, you need to enter the IP address of it. Suppose it is 192.168, but I need to attack on other device. If I am attacking on my router, it might be your network, our network might be disconnected. Okay, so what I'm going to do, I'm just checking any IP address of any other device that is connected to my router. This is my console of my router, and I can check currently how many devices are connected to my router. Now see, I have connected my mobile phone also to it, and it got the IP address of 192.168.0.2. Okay, now I'm attacking on my mobile phone. Okay, now what I'm going to do, I'm just trying to give this IP address 192.168.0.2. I lock it, so this IP address is locked. I'm now using the port 80, yes, on which this is a TCP port, and the method I'm using is UDP, as UDP is faster than TCP. It never gets an acknowledgements. Okay, and creating multiple number of malicious nodes virtually. Okay, you can use multiple 10, 100, lakh, so that simultaneously all the devices are transmitting the attacks. Okay, and now I am starting this content, and this is the way I'm attacking it. I'm starting attack. Now here you can able to see how many packets that can be transmitted and how many packets are sent towards this particular node. Okay, wait a while.
Your screen. Yeah,
And
your
it is
screen
working because it's a
blur.
heavy load. Okay, it's a huge number
Yes,
of
we can
packets or
understand.
threads simultaneously. Yes, now see, if you are observing here, it is request is started. Here, this counter is incremented tremendously. Wireshark. Okay, so I need to stop it, otherwise it will be polarize my network. So immediately, now see here. If you could observe at the bottom, I can stop it. See, whatever the packet UDP protocol, if you are observing here, source is my IP address. This is the IP address of my system. That is the laptop. Currently, I am connected to the Wi-Fi, and this is the destination IP address where I did the attack. Okay, and if you could observe the UDP protocol I have used. Okay, this is I'm talking about the locking, and here huge number of devices or packets have been transmitted. Now how we can come to know that the attack who is doing and at what system we are doing. So simply what you need to do, you need to go to the statics, go to the IP version 4 statics, and click source and destination addresses. If you could go to this, you come to know that the two different values. Okay, wait a while. Okay, it is currently working in state. Yes. Now see what happened. Now see, you come to know that you have the source IP address, you have the destination IP address. Now, if I want to know the attack is happen on which device, so I can go to the destination IP address and check on which IP address there is a huge number of packets are there sent. Now this is the IP address where huge number of packets currently sent. Okay, so this is the destination victim system, and who transmitted it. So I can go with the source and check. Yes, this is the value. So from 0.3, that is the my system, I have transmitted huge number of packets. Okay, so in this way you can go with the identification. But again, I'd like to show one thing. Now see, suppose I am using this, showing this TCP detail packets. I need to show, if I go to the protocol. Now see, you can come to know the version of protocol, that is the first 4 bits. Next 4 bits represent the header length. Okay, next one is the identification field, then the total field, then we have the identification. The flags can be set as 1 or 0. 1 means don't fragment, so fragmentation won't allow. 0 means your no more fragmentations will be allowed. Along with that, we have the header checksum, TTL, protocol used, and finally source and destination. So whatever we have shown in the header datagram format, you can come to know and see the details in Internet Protocol version. In the same way, if you want to find out the MAC address of your device, you go to the data link layer. Here the MAC address of your system and router, you can able to see it. In the same way, you can go with the TCP and see the kind of port we are using it. So everything will be available here. Okay, and you come to know that also. That is the one example I'd like to show. Next one, that is a TCP. That is the last one I can go with. Yes, if you are aware about the TCP handshaking signals, it is three-way handshaking signals. Yes, so means initially you send sync signal, then we have the acknowledgement plus sync, and then again it is acknowledged. Okay, so I need to show that also. So if we can go with, I can start it again, and I can simply browse. Suppose it is Rediff. Okay, so if I am going to the Rediff, the packets have been collected. Now simply I am going to the HTTP, and here this is the packet is going from my system to this HTTP. You can observe it under the HTTP. Here is the host. Okay, it's the rediff.com. Okay, and the sync one, the PCP I need to check. So I can go with the PCP and select any TCP value. Okay, so now if I'm saying this TCP, I need to go with selection of sync acknowledgement. Now this is the packet moving from, now if you're observing here, this is the sync packet which is coming from this port to 80. Now I should get the acknowledgement from 80 to this, again my system port number, and finally the acknowledgement. So these are the three packets. Three-way handshaking has been done if I am browsing the system. Okay, in the same way you can check for the fin packet as well, that is the termination packet. Okay, so in the same way, you need to first establish the session and you need to terminate the session, and based on that you can get the details of it on this Wireshark. And that is why Wireshark is very much important tool for doing the analysis on your packet, okay, in a detailed way. I think that's it, some brief idea about this particular contents. Okay, if the participants are having any query about it, okay, you can contact me or you can ask me here. Okay, and I'm sharing the feedback link again here, so you can go to the chat and please give the feedback again. Yes, this platform is now open to the queries. That's it from my side. Thank you. Yes, anyone is having the query? Now, as this is a brief, that is a brief introduction, that is the fundamentals of computer networks, and very soon we'll be going for its next version of this workshop, which is somewhat advanced in nature, and that could help you for going for the preparation of CCNA, that is Cisco Certified Network Associate, or CCNP, Cisco Certified Network Professionals. Okay, very soon we'll be starting that workshop. So stay with us with on your WhatsApp.
Hello.
Or the mail.
Sir, you're going to take a workshop on CCNA and CCNP?
That is the prerequisite for CCNA and CCNP.
Okay, prerequisites.
Yeah.
Okay,
yeah.
okay, great.
So that everybody should
Actually, the today's session also was very great.
Yeah. Thank you, sir. Thanks a lot. So I have shared the feedback in a chat box. Kindly give the feedback and mention your name properly, because that name would be getting on printed on your certificates. Okay, and that you are getting on your emails. Okay. So anybody would like to give some feedbacks, that would really help us. Yes, any kind of feedbacks?
Yes, actually, something was from me.
Yeah.
About the day before yesterday's session.
Okay.
Let me check with the snaps. Actually, I have taken a snap for that thing. I'll give you. Just give me 1 or 2 minutes, please.
Okay, so should I stop my presentation? That is
Yes, sir,
sharing
sure.
screen?
Yes, sir. Yes, sir. No worry.
Okay, okay, yeah, thanks. I'm stopping it. Yeah. Devre sir. Hello. Devre sir, are you there?
Yes, sir. Yeah.
Okay, okay. I thought that. Yeah. Yes, sir. Over to you, sir.
Yes. Thank you. Thank you very much, sir.
Yeah.
Very good evening to all. Let me take this opportunity to convey my sincere thanks to Prakash Sontake sir and his colleagues, Vas ma'am and Shirke ma'am. So it is indeed a pleasure to walk through with you people to understand what is computer networking. And I'm very happy to see a very young crowd who is attending these sessions. Okay. Me being a mechanical guy, it was always curiosity to understand what is computer network. If you ask me mechanical safety or industrial safety, mechanical point of view, I'll be very happy to share with you. But computer safety and security, yes, that is what it comes through the computer networks. So thanks for giving this insight. So I'll just very quickly go through, or overlook what we have been covered. But before that, I was just wondering to understand from, what are the opportunities that I'll be looking into. Now everybody is talking about blockchain technology. Then people are talking about AI, ML. The very essence of this blockchain or AI, ML, data analytics is nothing but data. So today we are struggling for fuels like fossil fuels or maybe electricity. In a similar fashion, data is a fuel for every individual person. And every now and then we are coming across not many unknown calls regarding fetching information from every individual person. And computer network is at the heart of this. Okay, so when we give a thought process for this, as an engineer, as an individual person, where will I find this application? So when I was going through this, I came across, the terminologies like data security, network administrators, network engineer, desktop support engineer. So if you see many of the job opportunities that most of the industries are providing, especially IT industries, so those are nothing but desktop support engineers. Network analyst, then system administration, system manager, network programmer, computer network support specialist. So these are some of the areas where you guys will be looking for, developing your own career. Having said this, so the very essence is to understand the computer networks. And Sontake sir, give a very good overview of what is ISO and OSI model, TCP, IP models. So this was really, good to understand the basics of networking. Then Vas madam took us through, difference between very fundamental models, those we quite frequently come across, like ISO and TCP IP models. So that difference was demonstrated by Vasma. Then what are different types of network topologies? Then when we call any network person at our home, so he always look at this packet transmission. So what exactly this packet transmission? So it was good to go through this packet transmission. And then thereafter, slowly we started unfolding actually what actually this computer network is. So understanding IP address, then subnet mask, subnetting. If you are studying in any of the engineering college or any organization, we always come across this subnet mask and subnetting. So what exactly these things are? These are basically protecting you and your identity from outside world. right? And for this purpose, we are using different tools. So tools are like, if I talk about tracing tools, Cisco packet tracing tool. So Cisco has become an inherent part of my life. Okay. So then how to design networking topology? So if you see every individual participant who is there in today's session, so tomorrow's world is in your hand. And you people are going to design, you people are going to protect, and you people are going to secure this, tomorrow. So in that case, this session was really helpful. So having said this, whether it's a networking devices, whether it's a networking analysis tool, or we are coming across various types of networking devices, wherein hub, network switch, NIC card, then router, and again understanding the various layers of TCP/IP. So Shirke ma'am give a quite good insight of this networking devices as well. And then finally, Prakash sir spoke about a Wireshark tool and then various commands to understand this process. So in outset, what I'll suggest is, see, look at the very essence of utilization of these technologies and how you can, this is basically a building block. And after this building block, you'll be exploring new technologies like I said, blockchain, right? So thank you very much for keeping these sessions interactive. And down the line, if you feel that something needs to be explored in a more typical way, in more detailed fashion, then Prakash sir and his team will be available to you guys. So I'll request you all to get in touch with those people, and definitely there will be hand holding in this process. So once again, I extend my thanks to Prakash sir, Vas ma'am, and Shirke ma'am for giving such wonderful sessions. And hopefully, we will continue this process down the line as well. I'll also request participants to keep an eye on this type of workshops here. So best wishes to all of you. Stay safe, do take care, and we'll connect to you all soon. Thank you. Prakash sir, thank you very much.
Yes, thank you very much, sir, for giving this opportunity, sir.
Thank you.
Yes, sir. Thank you. Thanks a lot.
Yeah, thank you, ma'am. So we declare this session as over, okay?
Yes.
Ketan sir?
I think Srinivas.
Yeah, Srinivas. I'd like to make a mention of Srinivas.
Yes, yes.
Srinivas, if you don't mind, can you please let us know your profile?
Actually, I'm working for EL2 support with ConnectWise. Recently, I joined. The thing is, actually, I have completed my MCA recently in the last year only.
Okay.
But still, I do have many more problems with the networking. So I joined that, and I'm very excited with the CCNA and CCNP prerequisite sessions, sir.
Right. Yeah.
Thank you so much for the great session, sir. Actually, it was great. Actually, I have completed some institute courses as well. But in 5 days only, you have covered all the things which I have covered in 2 years.
Oh, great.
Yes.
It was that's why I really appreciate your efforts and the support from the ma'am and Ketan sir as well, and you also, sir. Thank you so much for taking that much struggle for students.
Thank you very much. Yeah.
Thank you.
All credit goes to these 3 faculty members: Prakash sir, Vas ma'am, and Shirke ma'am, Sonal Shirke ma'am. So yes, these are the pillar behind this thought process and putting it to students. And we'll be very happy to see you guys once again. Many more such workshops will be coming up. And now this is a fundamentals of networking. So there are not many applications like we are talking about autonomous vehicles. Now see, within 3-4 years, you will say that you will not be seeing any ATM machines around you. Okay, so technology is rapidly developing, and at the heart of this technology, we'll see this computer network. So it is a good opportunity for all the students to take up this as a career. Okay? Prakash sir, over to you.
Yes, sir, sure. Thank you so much.
Yeah, thank you.
Thank you very much, sir.
Yeah.
Prakash sir, actually,
Yes.
I got that point which I mentioned just previously before the
Yes.
Narendra sir.
Yeah.
Actually, when you were explaining the Ethernet card, at the last time, at the last point, you have explained the types of Ethernet, right? So the standard 10 base T, 100 base T, and the one
evolution of Ethernet. Yeah.
Yes. So I wanted to add one thing, that the maximum distance cover
Yes.
could be possible by the medium, because the thing is, there is a limit, like how much LAN can be covered, how much 10 Mbps can be covered, and how much 1 Gbps can be covered.
Yes.
Right. So
Yes.
you can add that much only, sir. The one or two sentences will be there, but
Okay.
it will be very helpful, sir. Because see, what will be there, the students will get to know that at where or after how much distance repeater can be used, or the switch can be used.
Okay, that session, it is regarding the introduction of devices.
Yes, networking devices.
Okay, that is covered by Shirke ma'am. Yeah.
Yes, Shirke ma'am. Yes, sir. Yes,
Okay,
sir.
so what are the standard fast gigabit or 10 gigabit?
Yes, exactly.
That evolution that can be added with the help of some distances. What can be the distance between the devices?
Yes, sir.
Okay.
Actually, it is not like that much hard. If you want, I can give you the exact resolution or the exact amount of the distance.
Yes.
But that's okay.
Yes,
Well,
we
that
have
much-
that actually, that 10 base 2, 10 base 5, 10 base T. There's a huge evolution content with us. But because of the time constraint, I think that part was not covered.
Okay,
Yes,
sir.
very
Okay,
true.
sir.
Actually, we just had a session of 1 hour, and it was a great task for all of us to cover at least the majority of the contents, which would be useful on an
No, ma'am.
average to all the
Actually, you have
participants.
covered all these things. What I just mentioned with the Devre sir, that
Yeah.
you have all the things covered in 5 days, which I learned in 2 years.
Exactly.
That's
That's very
actually
true.
a big challenge for us.
It was a challenge,
Huge
yes.
content with the small amount of time.
Actually, you have filtered each and everything that which can be possible in that time,
Yes.
and you have used that time usage greatly. I really appreciate you all these three.
Okay.
Thank you. Thanks a lot.
Yeah.
Yes, sir. Thank you.
Yes.
I have to go.
After for the next workshop also, sir. Yeah.
Yes, sir. Sure. Please let me know as well.
Yes, definitely. We'll meet in your contact. Yeah.
Yes, sir.
Yes.
Thank you so much.
Thanks a lot, Srinivas. Thank you very much, Devre sir and Shirke madam.
Thank you, sir. Thanks a lot.
Yes. So I conclude this meeting, and I'm. Yes, thank you all the participants. Okay, we'll meet in next workshop, upcoming workshop. Thanks a lot.
Thank you, sir.
Thank you, sir. Thank you.
Yes.
Good day.